So that almost brings us to the end of our conditional logic exploration chapter. And we want to finish things off with a switch statement. Now, you may have heard the terms before control flow, and these are terms that describe how we essentially control the flow of how our JavaScript executes. And by using an if statement, we control the flow if something is true. If it's else, then the code will execute in a different flow. So to finish off our control flow in terms of conditional statements, we're going to look at the final one, the switch statement. Now, we'll take inspiration from some of the previous lessons and just create that constant that we know and also our result variable. So we got our number of 99, and you can probably assume what we're about to explore, something similar, just to give you the knowledge of what you need depending on which use cases. You can use an if, an else if, a ternary, and now the switch statement, which we're about to uncover in this video. So first things first, let's go ahead and just define that switch. Now, a switch is kind of like an if statement with lots of else ifs inside, lots of conditional checks, but instead of chaining this great big if statement, it gives us a utility to make things a little bit cleaner. So instead of doing if the number equals 1, equals 99, or equals 1,000, and repeating ourselves tons and tons of times, we can keep things nice and concise with a switch statement. So that's the idea behind why this exists. Now, a switch kind of looks like an if statement. So an if statement begins like this, and then we would pass something in. So let's take this for example. We have if a number. Now this will evaluate to true or false if we continue with the if statement, but we obviously want to use a switch. So the switch allows us to essentially look at this number variable and then respond to it in a cleaner way. So instead of having all these ifs and nested else ifs, we can keep things nice and clean. Now, what that looks like is where we introduce something called a case. So you may have heard the term a switch case. Add a switch case to the project, and each case is evaluated individually until we get to the bottom and exit the switch. Now again, it's important to know that this is declaring a new block scope. So again, our let result will act differently inside of here. So instead of saying if the number equals 1, we can in fact say if the case is 1, then we want to write some logic. So if in fact our case is 1, we're going to say that our result is in fact the text value of 1. Now the interesting piece is we'll go ahead and add another case for our number of 99, and we'll say result equals 90-9. Now what we want to do underneath this is console log out our result string. Now something interesting, you may have spotted it already, we have a lot of red underlines. So why might this be happening? Now without something like ESLint to guide us and say, hey, you're making an error, we could actually make a very bad mistake here and introduce some very hard to debug errors into our code. So if there's anything that you take from this video, it's remember to add a break statement. Now if we hover over this, we'll see this expected a break statement before the case. Now that is in fact talking about this case, which means we need to add a break statement just here. Otherwise what happens is this case is evaluated, and instead of breaking, it just continues on and it will keep evaluating every single case. Now this is called a fall through, which we try and want to avoid. So in good fashion, let's add another break to our case of 99. We'll go and fill this out and have a case of 1000, and we'll say the result equals 1000, and finally add that closing break. So when we go ahead and save this out, you can see that we have this result in our console of 99. I can go and swap this out, change this to number 1, and we have a number 1. Now because we're using ESLint, if we were to introduce an error to our code and delete a break statement, this is actually going to stop the compilation. So if I bring up my terminal here, you can also see that ESLint is expecting a break statement. So you can either keep your terminal open, keep the processes running, or you can hover over those red lines. Now, if you've got many files and many projects with lots of JavaScript code in, the terminal is probably the best place to catch all the errors because they will be printed in the terminal or even over here in our DevTools console. So let's go ahead with that in mind and undo those changes. So at the moment, we're kind of treating this as our if the case is 1, if the case is 99, if the case is 1000. So it kind of is an if and an else if built in to 1. But what happens if we want to get that else statement? So if none of these cases actually exist, for instance, if the number up here could be the number 55. Now we will in the console see undefined because we know our let result is declared and initialized with a value of undefined, which we can see in the console. Now to add a else statement, if you want to call it or think about it like this, and it's probably the easiest way of thinking about it, to add that else clause to a switch, we simply actually call this a default. So this means that this is the default thing or block of code which is executed should none of the cases match. So in this case, we can say the result is no match. So when we save this out, we get no match in our DevTools console. Now, some other interesting facts for you with our switch cases. If we were to have the number 1 as a string, this does not match against our case. However, if we were to change this to a number 1 and this to a number 1, the same thing happens. Now, interestingly enough, if we revert this one back to a number string, we then see a correct case match. So you can see how JavaScript is evaluating these, and the way that the comparison is made is with that under the hood triple equals. It's not using the double equals. If it was using the double equals, then this in fact would work because 1 equals 1 is true. And we can just show you that over here. So 1 equals 1 and then enter. You see that value is true. So in a switch statement, we're using essentially equals and then string value of 1, and they do not exist. However, a string value equals string is true, which is why we can go ahead and do something like this. So what does this mean? It means that we can use either numbers or we can use strings as valid cases in a switch case. Now there's also one more thing which is definitely worth mentioning, and that is the creation of block scope in these cases. So what we can do in this sense is after our colon here, we can wrap everything inside some curly braces. Now in this example, nothing's going to change, but we do know that we can create a variable such as const, and we can say text equals 1, and just for demonstration purposes, we'll override this. Now, what it also means that we can go into 99, we can say const text equals, and we can move up our 99 and replace that with text, and then finally close things off. So we'll save this and we can see things working perfectly as you'd expect. Now, if we were to get rid of these, something interesting would happen, and you can see that everything is now blowing up on us. Identifier text has already been declared. Now, because const and let are pretty much the same or behave the same inside a block scope, so with that curly brace definition, if you do need to create new variables or perhaps variables of the same name inside a switch statement, then this is a good way to do things by creating some new block scope. And ES6 or ES 2015 allows us to introduce these curly braces to give us that specific behavior. So there we are with our switch statement. Just to recap, we have looked at our number, we pass that into our switch, and then we evaluate each case individually. Optionally, we can create a new block scope. We need to remember to break after every single case. And here with this setup, ESLint takes care of allowing us and telling us when our errors are about to potentially happen. And we've also looked at that default case when nothing has matched. Now, unlike an if statement, this is nice and easy. We can just go ahead and extend it if we wanted to and add further cases to our switch. So that is it for this chapter on conditionals. We've covered truthy and falsy values. We've looked at if, else if, and else statements. We've looked at the ternary statement. And finally, we have covered the switch statement and the ways that we can use it and the different reasons why we might want to use it.